Hi guys and welcome back. So far I have shown you how the linear function works and how to easily plot it, and I just introduced it. Now I thought I should tell you what really it is called. Formally there is a word for that, and it is called the dual intercept method. Okay, so that is what we were doing. Now I just want us to talk about the algebra behind functions, because really functions are not anything different from what you have done in algebraic expressions. Functions are just algebraic expressions that are represented graphically in any way. If you like, you may say that. So if you think about this, say you've got an algebraic expression of degree 1, x plus 1. So we can just represent this as a function and say, well, f of x is x plus 1. Now we have established that this actually has a general form, and that general form is ax plus q. And we have established that on the graph, actually, this is the y-intercept, and that a there, in this case, it's one invisible math, and it's the gradient. That's what we have established. And we have looked at the effect of the gradient. Now, I just want us to look at the algebra behind functions. And quickly, maybe before I get into the algebra, let me just show you what I meant when I said the line y equals to 0 is just my x-axis. So if I'm going to plot the line y equals to 0, you can see it is here on the x-axis. You can see the x-axis has actually turned dark. If you don't see the difference, I should probably actually change the color of this line here and make it green so that you can see. That's the line y equals to 0. So if I plot the line y equals to -4, you can see it is going right to what? To -4, or -4 rather, on the y-axis. If I plot the line y equals to +3, you can see it goes on the point where y equals to 3. Okay, so and x is definitely 0. That's what you can see. And you can obviously think of the line, actually what the line x equals to 1 is going to be, what the line x equals to -5 is going to be. You can see these lines here, and obviously the line x equals to 0 is actually the y-axis. And of course, I can change this color and make it a little bit pink. You can see that's what we've got there. So basically, these are your horizontal and your vertical lines. Okay, if you want to represent them as an equation, this is basically how you will represent them. Now, I want us to quickly talk about the algebra of functions. In some cases, they will say, okay, where does this function find the point of intersection? That's what they will say. Find the point of intersection for a certain function. That is the common question that actually comes out, and I want you guys to see that. So suppose I have two functions. So I'm going to give you a nice worked example, and then we will use the Cartesian plane to prove our answers, our solutions. So let's see. Let's suppose you are given the graph y equals to -x plus 2, and the function also y equals to x minus 3. So obviously one of these graphs is going this way. I hope you know which one it is. And one of these graphs is going that way. Okay, of course, this is a random sketch. And we can clearly see at some point, these graphs are actually going to come together. Oh my bad. They're going to come together. So we need to find out, without sketching, at what point will these graphs come together. Now, so this is what we call point of intersection. Point of intersection. They meet there. Okay, intersection. You can use this nice word to maybe play smart over your folks and say, now I've got our point of intersection with my friend is actually the school gate. We meet at the school gate, if you get what I'm saying. So to find the point of intersection, you should actually equate the two to each other. The point of intersection is where the graphs meet, but it is actually where they have equal coordinates or the same coordinates. They can only meet if they have the same coordinates. So to find that, we solve algebraically where let me call this y1 and this y2. So we solve algebraically where y1 is y2. And so what does that mean? It means I'm going to have the equation minus x plus 2 is equal to x minus 3. And you can see now I can group like terms because this is the basic equation type that you kind of solved in grade 9. And then this is minus 2x, which is what equals to negative 5. And I divide by negative 2 both sides. You can see now that I am going to have x is equal to 5 over 2. Now, I must find the y coordinate. This is just the x coordinate. So to find the y coordinate, I can substitute either in that or that, it doesn't matter. But I'm going to take the easiest one, which is the one with a positive x value, 5 over 2 minus 3. So this is 5 over 2 minus 6 over 2. So I can see that in this case, the y coordinate will be a negative half. Now, let us see if this is the case. I know that a point of intersection is 5 over 2 and a negative half. 5 over 2, I hope you can see that in a decimal form, it is actually 2.5. So let's go for this. I just want to put up my grade so that I can actually have decimals in this Cartesian plane. So there come my decimals. So I'm looking for this point of intersection. The point of intersection, we have agreed it must be 2.5, it's here, and a minus a half. So this should be a point, this red one should be a point where the two graphs meet. So what I'm gonna do, I'm gonna plot these graphs and we're gonna test whether the algebra here was done correctly. There it is, one. The second one is y, the second graph is y equals to x minus 3. There we are. So we have found the correct intercept. We can see clearly that this is where actually the two graphs meet. So we have actually used two methods to determine the point of intersection. We first used the algebraic method, the approach, and secondly, we used the graphical approach. And we can see that these approaches actually agree. The last thing that I want to make you guys aware of is the fact that you can get graphs in a non-standard form. What is the standard form? The standard form, guys, standard form is the form y equals to ax plus q. Now, in a non-standard form, they can try actually, and they do this a lot, confuse you and give you the equation 2x plus 2y is equal to, say, negative 2. And they say find the gradient. Now, what learners do usually, they fall for the trap and say, oh, the gradient is always next to x, so then they say the gradient is 2. And then they go on to fight the teacher when they are marked wrong. You are wrong because this equation is not in standard form. You must first put it in standard form. How do you put it in standard form? Make y the subject of the formula, which is why you had to learn that in term 1. So this is going to be 2y is equal to negative 2x minus 2. And so y is actually, you divide by 2 throughout. So you see that this is minus x minus 1. Very, very important. So now you can see your gradient is not 2. Your gradient, or a, is actually a negative 1. So you even now get a clear picture that your line should be actually decreasing, not increasing. Okay, so be careful, watch for those pitfalls. I will also give you problems which I a little bit massaged and have got such issues. So that's about it for me regarding functions. I hope you guys have learned, in fact, the linear function, not functions. And in the next week or the next series, we will be looking now at the quadratic functions. I hope you've enjoyed. Keep well. Cheers.